Welcome to the App Inventor 2 course. The course will be divided into 4 stages: preparation, basic concept and frequently used documents, advanced components, project Pedometer. In the first lecture, preparation, we will progressively introduce App Inventor 2, installation, screen and basic operations, as well as compiling and execution. First, we will introduce App Inventor 2. App Inventor 2 is an Android-based development system created by Google and the Massachusetts Institute of Technology, MIT. App Inventor 2 is based on Blockly and developed via the cloud. The amazing aspect of this is that you can learn screen design and programming logic at the same time. After a brief introduction of App Inventor 2, let's talk about the installation. Before launching App Inventor, the computer environment must first be prepared. Firstly, prepare a Google account. Choose your preferred browser, such as Google, Chrome, or Firefox, etc., and configure the Android execution context. According to the above regulations, we need to prepare a Google account in order to register an account on the official website. Click Create Apps on the official website. Next, log in with your Google account. Pay attention, a Google account is needed. When a request approval pops up, click on Allow. After logging in, you can enter the project management interface, where you can create your projects. Since App Inventor 2 is an all-cloud environment, all the necessary steps are completed on the browser. Hence, there are certain software limitations. Please check for relevant version limitations and compare them with your computer's operating system, as well as browser version limitations. To successfully execute MIT App Inventor 2, Java needs to be installed on the computer. Since Java applications are popular, it is likely that your computer already has Java. Click on the link to test your computer's Java compatibility. After completing a project and getting ready to perform a test, you will need an Android operating system to do so. Hence, you need to set up an Android execution context. There are 2 ways to do so. The first involves using an Android smartphone or tablet. Please also check the operating system version requirements. The second approach involves using an emulator. This aspect will be explained in detail during the subsequent compiling and execution portion of the course. After the testing and emulator are completed, we will enter the project screen and basic operations. To start designing your project, firstly, you will see the project management interface. Switch to a language you are familiar with on the top right corner. If you wish to create or delete a project, click on Start New Project or Move to Trash, and a pop-up window will appear for you to name your project. The project name must begin with a letter. All projects will be displayed on the left. If you need to import or export a project, click on Project at the top. The best feature is that you can browse other projects in the gallery. After creating a new project, you will see the project interface divided into designer and blocks. If you wish to switch between the two, click on the top right corner to do so. In terms of the designer, this is the user interface for designing your project, as well as the screen the user will see. You can select a component on the right and drag it to the center of the viewer. The component will appear on the viewer, and the component's properties and alignment-related information. If you click on Blocks, you will see different colored blocks. Stack these blocks and the app will be executed according to the logic in these blocks. The blocks can be divided into built-in blocks and component blocks. Built-in blocks are control blocks, while component blocks correspond to the properties, methods, and events of the component. Detailed instructions on how to use these blocks will be introduced in subsequent courses. After completing the project, you can begin the testing stage. Hence, the project must be executed on the Android operating system. There are 4 ways to do this: Wi-Fi synchronization, USB synchronization, official emulator synchronization, as well as downloading and installing an APK file. You can choose a method to execute the test based on your personal preference and hardware. The first method is Wi-Fi synchronization, which is a preferred method thanks to its speed and convenience. Install the AI2 companion app on your phone. Connect it to the same Wi-Fi network as your computer. You should avoid using 3G, 4G mobile network or firewall, as it will prevent the program from operating normally. Click on Connect on the project page. Choose the first AI companion. Enter the code into your phone or activate the scanner to begin project testing. The second method is to use USB synchronization. Likewise, download AI2 Companion from Google Play. Connect the phone and computer using a USB cable. Choose USB and Connect to begin testing. The third method involves synchronization using the official emulator. You need to first install the official emulator AI Starter on your computer. After downloading it, install and execute AI Starter. After executing AI Starter, you will see a black screen like the one shown on the right. Don't panic, as this is perfectly normal. When it is connected to the emulator of your choice, wait patiently for the emulator to execute. If this is the first execution, the emulator's internal program must be updated. Hence, Install will appear. Simply click on Download and wait. If you click on Cancel while waiting, the process will start over again. So please be patient. After a while, when the emulator's internal program is downloaded, the project resources will be uploaded to the emulator. When everything is ready, the phone simulation screen will appear. Swipe right to unlock the screen. and you will see the phone home screen. After unlocking, there is no need to click on other apps. The emulator will display the MIT app Inventor2 screen. After several seconds, the computer will display the project-related information. The fourth method is to download the APK file. This method allows the project to be placed in the Android system. If you wish to apply this technique, firstly, there is a function on the top of the page called Build APK. Click on it and two options will appear: Build APK and display the QR code, or Build APK and download to computer. You can choose one of them based on your needs. Click on it and to generate the APK file. If you are using the QR code method, a QR code similar to the one above will appear after the APK file is downloaded. You need to scan the QR code with your Android device, and the project will be installed on the phone. If you choose to download the APK file to the computer, a file will be created after downloading is completed. You can install the file onto the Android device or computer emulator. After explaining the four aforementioned execution methods, let's compare and illustrate by using the chart. For the first method, Wi-Fi, you need an Android device and download an app to synchronize the data. And the same Wi-Fi is required. Although this is the most convenient method during testing, it is not recommended if no Wi-Fi is present. For the second method, USB, although no network connection like the Wi-Fi method is needed, the USB must stay connected during the testing process. For the third method, official emulator, although no Android device is needed, the emulator must be downloaded onto the computer, and some of the functions such as tilting or shaking will not be available for the emulator. The last method, APK file download, offers more flexibility in terms of whether you want to use an Android device or not, and there is no need to download synchronization software. However, every time the test is executed, you have to wait for the APK file to be downloaded and installed. The four methods apply to different situations, so the user can choose to use any method according to his needs. That's it for the first lecture on App Inventor 2 preparation. In the next lecture, we will officially introduce the components and relevant functions. Welcome to the App Inventor 2 course. In today's course, we will introduce the basic concepts and common components. The lecture will be divided into three parts, namely App Inventor 2 basic concepts, programming logic and common component introduction, and simple practice. App Inventor 2 offers a diverse selection of components. The designer may use the components such as label, text box, and button to design the designer. Then use component combinations and blocks to complete an independent project. Choose a component and drag it to the viewer. You will see the component's name and components on the right. This is used to identify or rename each component. All the components have their properties, methods, and events. After adding a new component, its default properties will appear. You can see the component's properties on the right and make adjustments. Switch to blocks. Click on the component to see the designer and blocks used. Divide it into events, methods, and properties. Logic is divided into two blocks, component blocks and built-in blocks. These will be elaborated on later. After explaining the programming control block, let's go into common components. To look at various blocks within the program, you will see different colored blocks on the screen. We can see there are many blocks on the screen. Besides the most obvious color difference, each block's shape and appearance are also unique. These will be introduced later. We can differentiate between the blocks via their colors. Look closer, and you will discover there are sockets and plugs on the blocks. Just like building blocks, you can insert the plugs into the sockets on the blocks. Pay attention to the shape of the blocks. The top of the block must be connected to other blocks, while the bottom does not have to do so. As mentioned, blocks are divided into component blocks and built-in blocks. As the name suggests, the component block controls component-related messages. Adding a new component will automatically result in generating the components-related block. Therefore, changing the component's properties, events, and methods can be accomplished through the component block. The built-in blocks are basic control blocks within the system. These basic blocks are generated automatically when you start a project containing multiple basic control blocks. We will talk about the three types of component blocks first. First is properties, which involves using programming blocks to control and set the component's properties. For instance, changing the color of the component and font size, etc. Next is events, which are used for notifying the execution of the component. For example, if the component button is clicked, then last is methods, which are the built-in functions of the component, allowing each component to be utilized independently. It can be used to control the actions executed by other components. For example, launch the text box and hide the keyboard. Properties is divided into dark green and light green blocks. It is used for setting or getting the component's properties. Dark green blocks are used for modifying the component's properties. Light green blocks are used for getting the values of the component's properties. Event blocks are brownish yellow and control the entry point of the program. It serves to notify the execution of the component. If you wish to execute other events after triggering the component, you must place other types of blocks in the event block to do so. Methods are purple, and they are the built-in functions of the component, used for controlling other components' executable actions. Every component has different methods blocks. Component blocks are the basic control blocks of the program. When a project is created, they will also be generated. Control blocks can be divided into 4 facets and explained: set relevant values, selection control structure and conditionals, computation and built-in commands, repeated loops. If you want to use the blocks to set relevant values, there are 4 data formats available: color, true/false, number, text. They can be placed together with other blocks to set the component's data type. If conditionals are needed, you can use the if, then, else block to control the conditions. Other types of conditionals can also be used. If computation and built-in commands are needed, you can use the computation and built-in commands to calculate or get the information. If you need to execute a certain event repeatedly, you can utilize the loop built-in block to control the repeat execution. Today we will talk about the common components of App Inventor 2. The following components will be explained in detail later. After introducing the above control blocks, let's talk about some common components. First is the screen component. New screens can be added using the screen component. Usually, the Screen 1 screen component will appear at the beginning. This is the default screen of the app. If you wish to switch screens, you may do so via block control. You can see the screen component blocks within the control flow of the built-in blocks. After logging in, you will see the project screen. If you wish to create a project, click on Project and New. Enter your project name. Click on OK. A new project will be created. Click again, and you will see this screen. We will first talk about the screen component. After creating a new project, the Screen 1 default screen will appear. Here it is, Screen 1. If you want to add a new screen, click here. You will be asked to name your screen. The system automatically names it Screen 2 for you. When you click on OK, a new screen will be created. You can see the difference here. It now reads Screen 2 and Screen 2's properties. We can also switch between Screen 1 and Screen 2. If you want to go to the earlier screen, click here. All the previous items will become available. The screen's attributes are displayed on the side. Along with other default values, you can freely adjust them. If you want to see its source code, since it is your new screen, it is also your component block. Click here, and all the component blocks will appear, along with their properties, events, and methods. This is a purple method block. You can use it. Second is the button component, which is commonly used for interacting with the user. Through clicking, holding, and releasing the button, you can trigger events and programs. Secondly, we will talk about the button component. Button can be found by scrolling down on the palette on the left. As you see, button is the first one. Click and hold, and drag it across. Here. There, you have your button. You can see that a button component has appeared under Screen 1. Over here, you can see the button's component properties, such as background color, font size, and font. In here, maybe we want to rename it Calculation, so after clicking on it, click on Rename. Button 1 will appear as the default. After clicking OK, the button's name will become Calculation. Then, if you want to change the text on the button, in the component properties, on the right, scroll down to find Text. All you have to do is change it to Calculation button. Press Enter, and the text will be changed. If you hover the cursor over it, it will tell you the component's name is Calculation. If you want to switch to another program, you can do so here. You will see that your calculation is separate from your built-in blocks because Calculation has its component blocks separate from the built-in blocks. Click on Calculation, and all of its built-in blocks will appear. As mentioned earlier, there are many different colors. If you scroll up, you can see the button has no events. Due to a lack of purple blocks, some of them, however, have event blocks. Third is the text box component, which allows the user to enter text or numbers. The default value is blank. If you want to get the value entered by the user, use the light green block to do so. You can tick numbers only. to force the user to enter only numbers. If you do not want the entered content to be seen by others, use the password text box. Okay, thirdly, we will talk about the text box component. The text box has some information here. This is what it looks like. It is a component where the users can enter information. Find the text box across for the user to enter information and drag it across. Don't release the mouse button. Hold, drag, and place it here. Once you move the cursor, it will be ready to create a component called text box. As you can see, there is a box here. The box allows the user to type in information. The same applies here. You can rename the text box. Let's change it to user input. Click on OK. The name will be changed. After changing its name, look at its properties on the side. Pretty much the same as what we just talked about. Then, come take a look at this. Text box also has its component blocks, such as when the users enter, do, etc. Or if I want to set user input to, here we can select user input, text color, or the user's text. You can use all of these, including adjusting the width and font size, etc. The fourth is the label component, or the common text that we see. It is generally used for outputting the displayed text data. You can use the dark green properties block to set the output values. Okay, we will take a look at label. Label refers to the text you see on the screen. It is not the same as text box. Text box allows the user to enter data, while label contains words that are permanently displayed. Drag it across and put it in. Its name and displayed text will be shown over here. You can rename it like this. And it will be renamed. If I want to change its displayed text, the same method is applied. Full name, and add a colon. Does this look familiar? When you see full name, it is unlikely that you will change the label. In other words, the label cannot be changed. It can be changed by you, but not the user. In other words, you can change it with the program, but the user cannot change the text on the screen. Click here to take a look at its component blocks. These are properties that can be changed, such as background color and font size, etc., or height and width, or where I want to point, or what values I want to set and get. The fifth is the image component, where you can upload image files for the phone app screen. Okay, next we will talk about the image component. The image component allows you to choose the images you want to display on the app. So you need to drag the image component across. Do not release the mouse button. When you see a blue line, you can release the mouse button. You can see I've already added mine. Over here are its name and properties. But if you want to display a photo of your choice, you have to upload it first. So you need to click on Upload File and Media and choose an image file. I've already uploaded a photo. Remember, the name can only be in English. If it is in Chinese, the system will alert you. Click on OK, and the file will be uploaded here. It has been uploaded already. Here you will see you can delete it or download it to your computer, but when you look at the screen, the image still hasn't been introduced to the screen. So remember to click on Picture and choose the media you've just uploaded. Click on OK, and it will appear. You can click here to see the image's components and properties. The sixth is the layout component. Since App Inventor 2 will place the new component on the top left corner, if you wish to align it to the center or the right, you will need to use the layout component, where you can relocate the component using the layout component. Okay, next we will talk about the layout component. The layout component is separate from the user interface component. Here you can see the user interface, and here is the layout component. Click on it and it will appear. There is a wide range of options available. Let's assume we want to adjust the horizontal arrangement. Click, hold, and drag it over here. You can see that it's a box. Although it doesn't seem to be doing anything, horizontal arrangement allows you to use it in conjunction with the other items we have talked about. For example, if I want to display 3 buttons together, when I add 3 buttons, you can see that they are displayed separately. What if I want to place them together horizontally? All you need to do is drag the button in here. After the first one, you will probably not see the difference. But once the second one is dragged in here, you will discover that yes, you've placed them side by side. The same technique is applied to the third one. Make sure that you place it in the box. If you place it on the blue line, it will not be inserted properly. It must be placed inside the box where there is no blue line. It depends on where you want to place the button. I choose to place it in the middle. It will be placed in the middle. It also has properties. Click on Horizontal Arrangement to see its properties. You can also adjust its background color or height, etc. In terms of horizontal arrangement, it also has component blocks, but it does not have an event block. After explaining the basic concepts and components, let's conduct a simple exercise. By designing a Bmi app to let the users enter their height and weight. Click on the Calculation button, and it will switch to another screen called Bmi Grading to calculate the user's BMI and display it on Bmi Grading. Click on Return to switch back to the original screen. There is a clear button on the original screen. Clicking on it will clear the user's height and weight. Refer to the BMI equation and grading standards. Before the exercise, you can follow the steps illustrated. If the user clicks on Calculate BMI, the calculation will begin and switch to another screen. Click on the Return button to go back to the original screen. Click on Clear to clear all the values. Designer. First, design the first screen, Screen 1. The complete screen looks like this. If blown up, you will see the screen contains label, text box, and button. You can name each component by following the illustration on the right. After every component is named, you can enter the text that will appear on the screen via the Properties section on the right. It is advised that you complete the designer before proceeding. This is the designer used during screen transitions. Click on Add Screen. Provide it with a name, and a new screen will be added. When the components of BMI grading is dragged out, each component can be named based on the illustration on the right. After all the components are dragged out, why can't you align them? Let's see how we can align these components. Can we use the Layout component to align the components? We want to place two labels side by side. So we need to add a horizontal arrangement and drag it to the viewer. It is a gray box. Drag the component to be placed side by side into the gray box. For example, drag the grading label into the gray box. You will discover that the gray box and the grading label are side by side. Next, drag label 3 into the existing gray box. You can see that the two labels are side by side. The default value of the labels will be blank because the calculation is not completed. Hence, you need to delete the displayed text of label 3 to get the same result as shown above. Have you noticed that the position of the return button is a bit off? If you want to position the button in the center, use the horizontal arrangement too. The property setting of horizontal arrangement is center and top, with gray background color. Lastly, set the button with a corresponding width. After the designer is finalized, you can begin using control blocks. The first logic-related concept is the global variable. The first concept is global variables. Global variables can be used anywhere in the program, and values within global variables can be accessed anytime. The values can also be edited. This is an important concept of control blocks. Let's see how we can apply global variables to this exercise. After entering the user's height and weight, the BMI value will be computed and displayed on the screen. Since the value is used across two screens, hence a global variable must be created first, and the value can be used in different screens. In terms of blocks, we need to set a global variable. Since the BMI value has yet to be calculated, set it to 0 at first. The second logic involves Bmi Calculations. After entering the user's height and weight, click on the Bmi Calculation button to begin computation. So, we know that the calculation will begin after clicking on the button. You can find such component-related logic in the component blocks. After clicking on the button Calculate Component, the component's component blocks will be expanded. When button Calculate is clicked, execute. Other blocks can be placed in the box. As mentioned during the concepts lecture, BMI will be calculated based on the values entered into the text box. After calculations are done, another screen, BMI Grading, will be launched, relaying the BMI variable. In terms of control blocks, it will look like this. The calculated BMI value is fed into the BMI Grading screen as the default value. After switching the screen, the BMI global variable is needed. Thus, after the screen has switched, the default value becomes the global variable. Since BMI calculation involves dividing the weight by the square of the height, you can drag the three text boxes onto the screen. The division block will be used, so let's drag it over here. Note that the height must be in meters, but the user entered the value in centimeters, so we need to convert the unit from centimeters to meters. By combining all of the above, we can complete the logic of BMI calculation. Set the calculation into the BMI global variable. Complete the BMI calculation. Next, we will talk about the concept of clicking on the Clear button. After clicking on the Clear button, all the values will be reset, including the user's height, weight, and the BMI global variable. When the user clicks on Clear, the user's input values and BMI values will be reset. When the Clear button is clicked, the text of the height and weight will be blank, and the BMI global variable will be reset. The screen above Screen 1 shows all the blocks. Next, we will talk about the logic of switching screens. After switching a screen, it must be initialized, start a new screen, and get the default values of the BMI calculation from the previous screen. When switching to the BMI grading screen, set the calculated BMI value onto the label and display it on the screen. Next, display the BMI grading portion. Grading is divided into 3 levels: overweight, normal, and underweight. In terms of control block selection, if else, the program will execute in a top-down manner. So, if BMI is greater or equal to 24, it will be graded as overweight. If it is not greater than or equal to 24, the next else if will be executed. If the result is less than or equal to 18.5, it will be graded as underweight. If the result is neither, then the BMI grade is normal. We will set an outcome for each of the 3 measurement ranges, using the label called Label Grading to display the result of each grade. If you click on Return, the BMI grading screen will be closed. Screen 1 will emerge. This is BMI grading screens blocks. Both the designer and the logic of both screens are completed. Everyone can take advantage of the 4 compiling and execution techniques demonstrated to you in the course. Pick one of the methods to conduct a test. This is the end of the lecture. Thank you for tuning in. Welcome to MIT App Inventor 2 Week 3 instruction video. Before beginning today's course, let's recap last week's content. Last time we introduced the basic concept of App Inventor 2, including how to design components and designer. Logic and common component introduction is divided into component blocks, built-in blocks, and common components. Lastly, we conducted a simple practice to calculate BMI and grades from designer to global variables. Firstly, after clicking on the user interface and palette, we will see the components and a list of components. Drag the component from the user interface on the left to the viewer to add the component, which can be renamed and deleted from the list of components on the right. On the right-hand side of components is a column of properties that shows each component's background color, font, height, and width, etc. There are two buttons on top of properties, Designer and Blocks, and the button with the darker shade indicates that you are in Designer, while the lighter button allows you to switch to Blocks. Click on the component you want and click on Blocks, and the column on the left corner of the page will turn into blocks, with the viewer being a blank area, much like a canvas for your component source codes. They can be divided into events blocks, methods blocks, and properties blocks. Blocks are divided into component block built-in blocks. Component block controls component-related messages. It can be used for changing the component's properties, events, and methods. Built-in blocks are basic control blocks within the system. These basic blocks are generated automatically when you start a project, containing multiple basic control blocks. There are three types of component blocks. First is properties, which involves using programming to control and set the component's properties. Dark green blocks are used for modifying the component's properties, while light green blocks are used for getting the values of the component's properties. Next is events, which controls the action of the component upon execution, such as if, then. Simply put, it controls the entry point of the program and notifies the execution of the component. Last, it is methods, which are built-in functions of the components. Each component can be used differently to control the actions executed by other components. For instance, call the text box and hide the keyboard. Built-in blocks are control blocks, which can be explained in four aspects. First is to set relevant values, such as color, true, false, Boolean value, number, or text, etc. Second is selection control structure and conditionals, such as if, then, else. Third is computation and built-in commands, such as elementary, arithmetic, or segment text, or starts at text. Last, it is repeated loops, such as for each number from, to, by 1, do, or while test, do. After recapping last week's course, we will now begin this week's course. Firstly, we will introduce the advanced components before conducting the practical assignment, Pedometer. App Inventor 2 offers a wide range of components. Basic components were covered in last week's course. So we will introduce advanced components in this week's course, including checkbox, notifier, and sound. AI2 provides numerous convenient components to facilitate app developments. It can also control robots through the Bluetooth function. If you have any questions about properties or methods, click on the question mark next to the component to see detailed information. Alternatively, right-click on the block and click on Help to link to the official website for further explanations. The first advanced component we will introduce is Checkbox, which allows for multiple selections. Enabling the user to check independently. Note: to check the box, you must check Checked in Properties instead of in Viewer. If it is checked, it represents true. If it is unchecked, false is the outcome. This true-false value is a Boolean data type. Later, we will use Boolean in conjunction with selection structure, such as the action to execute when the checkbox is checked or activate. The second advanced component is the Notifier. When using this component, a dialog window will appear for alert and message purposes. Note that it is a non-visible component and can only be shown on the app that has been installed on the device. When using the Notifier for alert purposes, we can see the following codes to indicate that when the button is clicked, the Notifier component will be called to display the alert message. Just like the error message in the red box. Another way to use the Notifier component is to display a message dialog. The relevant blocks are as follows. When the button is clicked, a complete message dialog will appear, as shown in the red box. What do the 5 blocks illustrated below represent? Message is like the content of an email. Title is the subject of the email. Button 1 and 2 are at the bottom. As for the cancelable button at the bottom, if it is set to true, it means one more cancel button is added. So there will be an extra cancel button at the bottom of the message dialog parallel to button 1 and 2. The third is the sound and player component. The sound component is suitable for playing short sound effects, while the player component is suitable for playing longer music. Both are non-visible components. The files must first be uploaded to media before setting the source properties. Next, we will introduce the fourth advanced component, Timer. Timer is located under Sensors in the palette on the left. It will not be visible when it is dragged into the viewer, and it will be shown at the bottom as a non-visible component. You can configure the timer in Properties. If you want to keep time while the app is executing in the background, check Timer Always Fires. If you want the app to keep time as soon as it is launched, check Timer Enabled. The timer interval is in milliseconds. The next advanced component we will introduce is the Accelerometer Sensor, which can be found under Sensors and Palette. It is also a non-visible component. Accelerometer Sensor is used mainly for detecting shaking and measuring acceleration approximately in 3 dimensions XYZ. When acceleration changes are detected, some programs will be executed. Lastly, we will introduce the Pedometer, which is also a non-visible component found under Sensors. The new sensor component is the advanced application of the accelerometer sensor. It can be utilized to calculate steps and distance. In the early years, when this sensor component was not available, we could only estimate the number of steps by calculating the changes in acceleration. Now this component can help us detect the number of steps and distance traveled. In the subsequent project, we will let everyone apply this sensor. Let's get started on the exercise. First of all, this is a pedometer practical exercise starting from scratch. Hence, we need to explain its development process. We can see the pedometer-related functions, such as steps, BMI, elapsed time, and feedback. In the last course, we learned how to calculate BMI, so we will apply the pedometer component to design the step counting and elapsed time functions in this course. Next, we will expand to speed, calorie calculation, and feedback mechanism, etc. In the beginning, we will explain how to let the device detect the user's steps based on shaking. The step counting functions are divided into 3 types: stop, start, and reset. When clicking on the Stop button, we need to make the pedometer stop. When clicking on the Start button, the pedometer will be activated, and the number of steps taken will be shown on the screen. If you want to reset the accumulated steps, click on Reset, which will stop the pedometer and reset the accumulated steps on the screen. Let's begin by talking about the step counting function. First, drag the pedometer component to the viewer. There are 3 buttons: Start, Stop, and Reset. The step label is used to display steps and the all-important pedometer component. Remember the horizontal arrangement that was taught in the last course? We can apply horizontal arrangement to the 3 buttons here. Refer to the naming method on the screen. After this is completed, you can begin to design the logic. How do we create the pedometer stop button? Let's think about how it works. When the stop button is clicked, the pedometer function will be shut down or stopped. When designing the blocks, we can design them in a way that when the stop button is clicked, pedometer 1 will be stopped. After setting the stop button, it is time to design the start button. Let's think about how it works. When the start button is clicked, we will activate the pedometer component and display the steps on the screen. When designing the blocks, after clicking on the start button, we will call or start the pedometer 1 component. What do we do next? We haven't yet defined the actions to execute after starting the pedometer, right? After the pedometer is started, we want to detect the steps and display the steps label. When designing the pedometer to detect the number of steps taken, we need to set the steps label's text. We can use joint text in conjunction with the block used for getting the steps value, where walked steps is displayed together with the steps value using joint text block. The last button is Reset. This is how it works. When the user wants to reset the accumulated steps, the pedometer is stopped, and the accumulated steps on the screen are reset. So after clicking on Reset, we have to do 3 things: stop the pedometer, reset it, and display the reset value on the screen. Hence, the pedometer component is reset. Then, stop counting the steps. Next, set the steps label by replacing the existing steps value with the number 0. Let's recap on the source code of the pedometer function. First is the stop button, which will stop the pedometer when clicked on. Next is the start button, which will call the pedometer. When clicked on to activate step detection and display it on the screen. Last is the reset button, which will reset and stop the pedometer when clicked on before resetting the steps label to 0. Next, please think about whether the steps and distance obtained by the pedometer are accurate. As advanced as it is, the modern pedometer inevitably generates some inaccuracies, but what are the potential causes? For regular pedometers to work accurately, they should be placed on some part of the user's body, such as the waist or inside pockets on the pants. In this way, the measurements will be much more accurate than holding the pedometer in the hand or keeping it in the bag. Another possibility is whether the step counting will continue when the app switches background, such as during an incoming call. In order to increase accuracy, we recommend using a wearable device such as a fitness bracelet, which allows the device to be held in place securely without the problem of switching backgrounds. More importantly, it can continue to monitor your exercise progress throughout the day, even if you do not have your phone with you or if your battery is dead. After the pedometer function, let's talk about the timer function. Next, we will learn how to use the timer to display the timer function. First, we need to add a second label and a timer. If you want the app to keep time as soon as it is launched, check Timer Enabled in Properties. However, the exercise dictates that we only begin timing after the Start button is clicked, hence the Timer Enabled must be unchecked. Also, the interval must be set in milliseconds, since 1 second equals 1,000 milliseconds. Hence, the timer interval should be set at 1,000 milliseconds. Next, the 3 buttons we created earlier, namely Start, Stop, and Reset. Lastly, the seconds label that updates the figure on the screen every second. Just like the pedometer, clicking on the 3 buttons should generate the corresponding outcome. The only difference lies in replacing the pedometer with the timer. After clicking on the Stop button, the existing content of the pedometer will be executed, but we must add the timer content. Clicking on the Stop button stops the timer. The timer is set to either true or false, each representing turning on or turning off the timer. If the timer is on, a signal is sent to the sensor to generate an event. If it is off, then it is set as no, and no signal will be sent to the sensor. Next, when clicking on the Start button, besides turning on the existing pedometer component, we need to activate the timer component as well. Hence, we need to connect true to the back of the timer component to turn on the timer component. Next, we will set a global variable to document the seconds. When the timer is started, every second will be refreshed and displayed. We need to make the timer update the seconds every second. In other words, add 1 second to the timer every time. Hence, 1 second will be added to the global seconds displayed in the seconds label before it is displayed. Next, we will design the timer stop program. To stop the timer, we must add the reset program onto the existing stop button. To recap on the timer resetting mechanism, we need to first stop the timer. Hence, the timer here is set to false. Next is to reset the seconds, or set the global seconds to 0 and display it on the screen. We have finally completed the timer function. Let's recap on all the source codes. First is the start-stop program. When the start button is clicked, the pedometer will be called and activated along with the timer, setting the value to true. When the stop button is clicked, the pedometer and timer will be called and stopped, setting the value to no. Next is the timer function. We first set a global variable to 0. When the timer is started, 1 must be added to the seconds before it is displayed on the screen. Lastly is the reset function. When the pedometer is reset and stopped, besides resetting the steps label to 0, we also need to turn off the timer or set the value to false before resetting the seconds of the global variable and displaying it on the screen. We believe that everyone has completed and understood the principle of the source codes. Now, connect your Android devices and try it for yourselves. Before the class ends, please think about the following. When the user stops walking and does not click on the stop button, does the timer continue to keep time or not? If the runner stops walking or running on the treadmill, the timer should be stopped. The same principle applies to pedometers, hence the timer should be off when the user is not in motion. So, how do we let the timer stop automatically? Can we configure the pedometer in a way that when the steps or distance is not changing, it will stop? You should try to design the source code yourself. In the next class, we will continue to elaborate on other functions of the practical exercises. Thank you for listening. Welcome to MIT App Inventor 2, Week 4 instruction video. Before we begin, let's review last week's session. First, we've learned two components from the user interface, one being the checkbox, which allows checking multiple boxes at once. What else do we have to look out for? Remember to check Checked from Properties and Not from the viewer. Also, remember there are two options for the checkbox, including Checked or Enabled. These can be used in conjunction with If, Then. Next is the Notifier component. Remember, it can be used for alerts or messages. When it is used for alerting, it can be combined with an alert message source code to display the alert message. Another notifier function is messaging. Remember to distinguish between message, title, button, text, and cancelable. Also, the true or false of cancelable does not represent whether the cancel button will exist. Next, in the media section, we introduced the sound and player component. The sound component usually plays short sound effects, while the player component plays longer music. Lastly, there are the timer, accelerometer sensor, and pedometer components within sensors. In particular, for the timer component, we must be careful that if we want the timer to keep on timing while the app is executing in the background, timer always fires must be checked. If you want the timer to start when the app is started, remember to check the timer enabled box and that the timer interval is in milliseconds. Furthermore, the accelerometer sensor detects acceleration changes along the XYZ axes, not only two-dimensional space. Lastly, the pedometer component is the core of our exercise, and it detects steps and distance. Remember to distinguish between the two. Now, let's practice last week's pedometer source code, which is divided into stop, start, and reset. When the stop button is clicked on, the pedometer will be stopped. Next is the start button. When clicked on, it will call and start the pedometer to detect the steps and display them on the screen. Last is the reset button. When clicked on, it will reset and stop the pedometer before resetting the steps labeled to 0. Next is the timer function source code. The programs for start and stop look similar. When clicked on, the pedometer will start or stop, followed by whether starting the timer is true or false. Does everyone remember the difference between true and false? That's right. It is starting or stopping the timer, and whether it will send a signal to the sensor and generate an event. Next, set a global variable to 0. When the timer starts, 1 second must be added to seconds and displayed on the screen. Last is the reset function. After the pedometer is reset and stopped, the steps label is reset before the timer is stopped and set to false. Lastly, the seconds are reset and displayed on the screen. After a series of warm-up exercises, let's get to this week's course. Next, let's start this week's advanced pedometer exercise. After designing the basic pedometer last week, we will add several advanced functions that are divided into 3 themes. namely speed, calorie calculation, and feedback. Let's review the development process. Last week, we used the pedometer and timer components to design the pedometer and timing function. This week, we will design the speed, calorie calculation, and feedback mechanism. Now, let's dive right into the first part, speed. First of all, we need to understand what speed is. Average speed is obtained by dividing the distance between 2 points by the time traveled. How do we obtain the two major elements of distance and time? We can use the pedometer component to measure the distance and time, which is something we learned last week. Now, we need to add the calculated speed to the speed label and display it on the screen. The pedometer component can measure the number of steps and distance. The steps program we designed earlier is to display the number of steps taken in the steps label. Now, we need to add the distance measurement. But the difference is that we want it to be a global variable rather than a local variable. Hence, we must add an initialized global variable walk distance to access distance. Moreover, note that the distance is measured in meters. As for time, we already used the timer in conjunction with the global variable seconds last week to record seconds. Refresh it every second and display it on the screen. Now, we only need to combine the two source codes by using the global variable walk distance or distance and the global variable seconds or time to calculate speed. Next, we need to add speed calculation by placing the newly added speed label under the timer to be refreshed and displayed on the screen like seconds. The only difference is that the value is changed to divide the global variable distance by the global variable time. The unit is also changed from seconds to meters divided by seconds. Isn't speed calculation just too easy? Let's add another function to distinguish between quick and slow. Whether one is walking quickly or slowly is determined by speed. When one walks further in the same amount of time or takes less time to walk the same distance, it means one's speed is faster. We can categorize speed into slow walk, normal walk, or fast walk. Please refer to the picture for the relevant data. Let's create a speed level label to store the speed label we want to display. If the speed is lower than 50, it is classified as a slow walk. If the data does not fit the description above, it means that the speed is higher than 50 but lower than 100. We will classify it as a normal walk. If the data fit neither of the two above descriptions or are higher than 100, we will classify it as a fast walk. If the selection sequence is reversed, will the answer be different? The answer is yes. If we first determine whether the data is lower than 100 before determining whether it is lower than 50, if the speed of 40 is entered, the "is the speed lower than 100" route or normal walk will be taken, and the program will not determine whether 40 is considered a slow walk. If multiple selection structures are needed, click on the gear to add new blocks. In this way, you can add else if and else besides if. Time to stimulate your brain. Of the minute, second, and millisecond conversions, which one do you think is more meaningful? As a matter of fact, no matter what method you apply, the value remains the same, just like the fact that 1 minute and 60 seconds are the same, the only difference being the scale you wish to use. If I work out for 1 hour today, I will probably care about my speed per minute. If I work out for only a few minutes, I will care about my speed per second. As for cars or other forms of transportation, speed per hour will be utilized. Next, if speed per minute is chosen, how do we calculate it? There are 2 answers below for your reference. One is to add a new timer component, and the other is to use the same timer component. Here is a tip for you. You can apply the concept of 1 minute equals 60 seconds, hence by dividing seconds by 60 to see if the remainder is 0. You will be able to know if it is a full minute. Lastly, what are the other data that affect speed level? Factors like height, stride, or as mentioned last time, whether timing continues during break time, all influence the outcome. Now we will add the calorie calculator. The burning of calories is directly related to the speed of walking, meaning that the faster the speed, the more calories are burned. Please refer to the table for a calorie calculation. The units are calorie, minute, and weight in kilograms. To convert calories, we need to know the user's weight in kilograms. So we must create a text box for the user to enter his weight to display calories burned in the calorie label. How do we go about designing the weight text box? The horizontal arrangement we learned earlier will be useful here again. Use horizontal arrangement to put the label 1 and weight text box next to each other to create a decent text box with a message function. Next, don't forget the calorie label. After creating the calorie label, we need to think about the display arrangement. We will combine text burned plus value plus calories. But how do we calculate the value? All we need to know is that calorie burned equals speed times minutes times weight. So the number we put here is speed. Distance divided by seconds times minutes, seconds divided by 60 times weight. Remember to place the source code under the timer immediately after the speed level. Next, please think about what other data are relevant to calorie calculation. Basically, factors including physique, workout strength, or the equipment used all determine the number of calories burned. For example, swimming, rope skipping, and jogging involve different intensities, resulting in different levels of calories burned, so the speed is not the only determining factor here. Let's take a look at the feedback mechanism. First of all, we need to use the Notifier component in the advanced components. When a sufficient number of steps or distance has been reached, a window can pop up to display words of encouragement. Remember, the Notifier component is a non-visible component. What should the feedback display look like? Firstly, we can set that a window will pop up for every 100 steps taken to encourage the user to keep on going. Next, we can design a button called I Will Persevere for the user to motivate the user. The following is the source code for our feedback mechanism. If the remainder of the number of steps taken divided by 100 is 0, what does this signify? That's right. When the number of steps taken is the multiple of 100, Notifier 1 will be called for every 100 steps. This is combined with the join text output of Congrats, you have already taken steps. Note that it is displayed as a message. This is followed by the title Please Keep It Up and the I Will Persevere button. Time to stimulate your brain. Besides the encouragement notifier, what other feedback mechanisms can you think of? Here are some tips. We can use the advanced component from earlier to play some victory music or display how much your BMI has decreased. Or you can change the variable every 100 steps to every 100 calories burned. After learning so many components, we believe you're capable of enriching our pedometer by applying your knowledge and imaginations. In the next class, we will continue to talk about the remaining functions of the practical exercise. Thank you for listening. Welcome to MIT App Inventor 2 Week 5 instruction video. Before we begin, let's review last week's course. The first is the speed function. We use the pedometer component to measure distance, before using the timer to measure time. Last week, we displayed the calculated speed in the speed label and on the screen. The pedometer we designed before only detects the number of steps taken and displays it in the steps label. Since we now need the distance measurement, we need to add an initialized global variable walk distance to access distance. As for time, we already utilized the timer component in conjunction with a global variable seconds the week before last to refresh and display seconds on the screen every second. Consequently, we also use the global variable walk distance and global variable seconds or time to calculate speed. Lastly, we will add the speed calculations where the speed label is placed beneath the timer so that it is updated every second and displayed on the screen. The value used is derived by dividing the global variable distance by global variable seconds. Next, we can categorize the speed into slow walk, normal walk, or fast walk. Create a speed level label and add a conditional source code. If the speed is lower than 50, it is classified as a slow walk. If the data doesn't fit, meaning that the speed is equal to or higher than 50, then we should determine if it is lower than 100. If it is lower than 100, it is classified as a normal walk. If the data doesn't fit the condition, it means that it is higher than 100 and will be classified as a fast walk. Next is calorie calculation. We need to know the calorie burned equals speed times minutes times weight. So we must create a text box for the user to enter his weight to display calories burned in the calorie label. We use horizontal arrangement to arrange label 1 and weight text box next to each other to create a text box with a message function and add the calorie label. What should the calorie label test read? The number we put here is speed times minute times weight. Speed, distance divided by seconds, times minute, seconds divided by 60, times weight. Place the source code under the timer immediately after the speed level. Therefore, we now have speed calculation, speed level, and calorie calculation under the source code. Lastly, our final exercise last week was the feedback mechanism, where we designed that for every 100 steps, the Notifier component from the advanced components will pop up to encourage the user to keep up his efforts. Next, we also designed a button called I Will Persevere. Let's take a look at the source code. When the remainder of the number of the steps taken divided by 100 is 0, it means that Notifier 1 will be called for every 100 steps taken. This is combined with the message, "Congrats, you have already taken X number of steps," and the title, "Please keep it up," as well as I Will Persevere button. Before beginning this week's course, let's review the development process. In week 3, we covered the pedometer and timer functions. Last week, we introduced the speed function, calorie calculation, and feedback mechanism. This week, we will conclude the pedometer design by showing you how to calculate BMI and database. This week's advanced pedometer exercise is divided into 2 themes. In terms of BMI design, we need to apply what we've learned in week 2, while the database saves the hassle of repeat entries for the user. After a series of functional designs from earlier on, our screen 1 should be pretty much full. To prevent too much information on the screen, we should add another screen for displaying personal information. Hence, we will add an information button at the bottom of the screen. At the top of the screen, there is an Add Screen button. Click on it and enter the screen name information. How do we design the screen display? When clicking on the information button, we will open a new screen, Information. What information does the information screen require? Firstly, set a reminder label before the height text box. This is followed by the weight reminder label, the weight text box, and the calculation button, which, when clicked on, will calculate and display the BMI values and weight class. There is a return button below the BMI label and weight class label, which, when clicked on, will take the user back to the original screen 1. Do you still remember how to calculate BMI? First, we add an initialized global variable called BMI. When the calculation button is clicked on, set the BMI variable's value. Do you remember the BMI equation? Dividing the weight by square of height. Note that the height is measured in meters. Our source code converts centimeters to meters by dividing the height by 100 before executing the height squared and dividing the weight by the square of height. Next, remember to set the label BMI's text using join text. Your BMI value is plus global variable BMI's value. If the BMI value is higher than 24, the user is overweight and the weight class label will display, "You are overweight, keep it up and walk more." If the above condition does not stand, it means that the BMI is lower than 24 and we need to determine whether it is higher than 18.5. If the value is between 24 and 18.5, it means that the user has normal weight and the weight class label will display, "Your weight is normal. Walk every day to maintain your health." If neither of the conditions applies, it means the user is underweight and the weight class label will display, "You're underweight. Please exercise more to increase your muscle mass." What do these conditionals remind you of? That's right, speed level determination. You can try to compare the sequence of the conditionals between the two. Next, we need to design the return button. When clicking on the return button, our original screen will be closed and return to screen 1. In terms of the source code, when the return button is clicked on, execute close screen. Let's review all the source codes. Let's add an initialized global variable BMI. When the calculation button is clicked, the BMI value is calculated by dividing weight by the square of height. Next, the label BMI's test is set to display. Your BMI value is plus global variable BMI value before conditionals are used to design the label weight class and display text such as for overweight, normal, or underweight. Lastly, we will add another control block that turns off the screen when the return button is clicked on. Next, we will talk about the last part, database. First, we need to contemplate the reason for a database. We can enter the user's height and weight on the information screen. But every time we launch the app, they must be re-entered, making it a hassle for the user. Therefore, if the data can be stored automatically, it will be more convenient to use. Does the database also have its related components? Certainly. It is the TinyDB component under storage. The data item of the TinyDB is stored under the label in string format. In other words, each data item stored requires a dedicated label that is used later to read the stored data. Each app only has one data storage area that can be used for transmitting data between different screens. Lastly, the TinyDB is also a non-visible component. After the weight is stored in the database, the user doesn't have to re-enter it every time, and the weight text box can be removed from screen 1 to prevent repeat entries in screen 1 and information. To let every screen use the database, we need to add a TinyDB to every screen. Note that this is a common database. As we mentioned before, there is only one TinyDB in every app that is shared by different screens to transmit information. Next, we will add a Save button to let the user store the information he has entered. Let's think about how many data entries do we need to store. The answer is 2. Simple. It's height and weight. Therefore, we have 2 labels in the database called height and weight, as well as 2 data entries that must be stored in the label, height text box and weight text box. How do we go about designing a database's source code? When the Save button is clicked on, we need to call the database to store the value. The first is height, where the label is height. And the stored value is the height text box. The second is weight, where the label is weight, and the stored value is the weight text box. Next, we must set it in a way that when there are data in the database, the information screen will automatically read the database's warehouse without requiring the user to enter it repeatedly. We need to initialize information or set it so that it will automatically read the database's data when the information screen is opened. If there are no data, the default value is 0. For the source code, call TinyDB1 to acquire the data. Label height, when there's no label, the value is 0. This is used to set the text for the height text box and weight text box. Previously, we talked about removing the redundant weight text box in screen 1 and calling the database instead. Hence, let's delete the text box by clicking on Delete, and the text box will be removed from the screen. Do you remember what the weight text box was used for? It is used for calculating the BMI value, so we need to change the weight portion of the BMI calculation to call for the value by calling the database to obtain the value of the weight label. When there is no label, 0 will be sent to indicate that there are no data. Time to stimulate your brain again. There are two database-related problems for you to think about. The first is when the user has entered no data or label equals 0. How do we remind the user to enter the data? We can address this problem from a conditional point of view. When the wait text box is 0, an alert window notifier component will emerge or play an alert sound. Secondly, besides height and weight, what else can we store? Not only repetitive entries require storage, fitness bracelets calculate the number of steps taken or heart rate every day. Hence, we can store the accumulated steps into the database daily to determine how many steps have been taken in total, how many times it has been recorded, or the trails recorded. After all the functions have been completed, let's think about other functions that can be added, as well as what methods or variables can be used. I hope everybody has completed their pedometer. Thanks for tuning in. Welcome to MIT App Inventor 2 Week 6 instruction video. After 5 weeks of courses, do you find them fulfilling? Have you learned tons of new information and functions? After the course is over, can we continue to design projects? Absolutely. Next, we will show you where to draw inspiration for your projects and how to design them. If you have no idea what you want to do, or if you just want to follow the video, click on Gallery on the top right corner. Nearly 200,000 projects are awaiting you. You can also follow the video of the projects that other people have come up with. After clicking on Gallery, you will see instructions with website links and videos. If you find something you fancy, you might also browse the designer's other creations. They are located inside the white box on the right. Another approach popular among technophiles is to Google it. Simply type in the keyword to find lots of teaching websites or design examples. It is time for you to come up with your unique projects and design them. Perhaps little games, calculator, clock functions, or photo designs. We suggest you make a list of ideas before discussing their feasibility with your team or teacher. Remember to conduct constant testing during the process. After 5 weeks, we hope you have learned plenty of new knowledge, and we hope that you have enjoyed the course and exercises. Have a great brainstorming session, and we hope you will complete your design. Thanks for listening.